Welcome back. Today I'll teach you how to win at Swine in a Line. As I mentioned in the second video, the strategy for winning swine in a line involves looking at the sum of the positions occupied by the pigs. For instance, the position where there are pigs in pens 2, 7, and 9 has value equal to 2 plus 7 plus 9, or 18. But all that really matters is the last digit of the sum. Here's the fact that unlocks the game. When a player makes a move, he or she can change the last digit of the value to any other digit, but the last digit cannot stay what it was. In our 279 example, where the value of the position is 18, adding a pig in position 1 will make the value 19. Adding a pig in position 9 will make the value 27. Adding a pig in between can get you any value in between that you like. So the 9 values you can get by adding one pig are the numbers 19 through 27, which together have every possible last digit except 8. Now, you may be thinking I've forgotten about what I call consequences, which are the jumps that take place when some pen has more than one pig in it. I haven't forgotten. Those consequences don't change the last digit. Let's see why. Say it's my turn and I put a pig in pen 2. Before the consequences, the value is 2 plus 2 plus 7 plus 9. Left, right. After the consequences, it's 1 plus 3 plus 7 plus 9. The same number. We've traded 2 plus 2 for 1 plus 3, so the total value doesn't change. Okay, but what if instead I put a pig in pen 9? Before the consequences, the value is 2 plus 7 plus 9 plus 9. Left, right. After the consequences, the value is 2 plus 7 plus 8 plus 0. We've traded 9 plus 9, which is 18, for 8 plus 0, which is 8. So the total value of the pigs goes down by 10. But this doesn't change the last digit. You can check that any time you take a pen with 2 pigs in it and send them elsewhere in accordance with the rules, the total value of the pigs either stays the same or decreases by 10. Either way, the last digit doesn't change. Now, neither of the moves I've shown you is the winning move. The only way to be sure of winning from this position is to put a pig in pen 7, which makes the total value of the pigs end in the digit 5. Check it. 2 plus 7 plus 7 plus 9 equals 25. Left, right. Check it again. 2 plus 6 plus 8 plus 9 still equals 25. Now it's your opponent's turn to move. Whatever your opponent does will make the total value of the pigs end in a digit different from 5. Consequences won't change that last digit. Then, when it's your turn, you can make a play that makes the total value of the pigs end in a 5 again. Consequences won't change that either, and so on, back and forth. If you stick to this strategy, it'll be you that gets to make the total value of the pigs equal to 45, thereby winning the game. Now, technically, what the place value argument shows is that if you keep following the make the sum end in a 5 rule, you can't lose. What it doesn't prove is that you will eventually win if you use this strategy. I mean, how do we know the game won't go on forever? That's a trickier problem, and I'm not going to prove it here. The question I'll address in the fourth video is, what can we learn from this puzzle? The idea of using place value is illuminating, but where do illuminating ideas like that come from? Is there an approach to thinking about problems that leads you to invent ideas like that? In the meantime, I invite you to consider a variant of the game. In this variant, when there are 2 pigs in the same pen, one pig goes left and the other goes back into the field, except for one special case. If we ever get into a situation in which there are 2 pigs in the leftmost pen, the player who made this happen immediately loses the game. I call this the one left, one out variant. Can you figure out how to win at this game? Stay tuned.